So now in the previous tutorial we have learned about atomicity, okay, and isolation. Now we will talk about durability and what? Consistent. So first of all, once the user has been notified that the transaction has completed, $50 has taken place, the update of the transaction must persist even if there is software or hardware failure. Okay guys, suppose we have deduct $50 from A and received at 50, and suppose at the time of write our system got failure. Okay, so what happens, our transaction will happen, the three step will happen, but afterward instruction will not happen due to failure. So what happened, it creates the inconsistent. So durability say that if happening this thing, just roll back the at the initial step. You have started your journey from here and you reached here, and at the time your system will fail. So what you will do, just roll back to this and reach at the initial state and start again whole process, whole transition. So this will remove the inconsistent. Okay, so that's what durability said. Now come to the consistent. What is consistent? Suppose our database has some values, okay, and we have performed a transaction, okay, and after performing transaction our database again inconsistent, okay, no redundant. Suppose there is no failure, at that point it is not failed, okay. So what happened, it will execute all these three instruction, means six instruction. So our system will be in consistent mode. But if there's any failure, okay, so it will leads us to a inconsistent state, so we don't want that state, okay. So in general, consistency requirement include explicitly specified integrated constraint, primary key and foreign key. We have studied all these things. Implicit integrity constant, sum of balances all the account, okay, minus of sum of loan amount must equal value of cash in hand, okay. So what it is saying, a transaction when starting to execute must see a consistent database. Okay. During the transaction execute, database may be temporarily inconsistent. That's not problem. When transaction complete successfully, the database must be consistent. It's a must. If in our first stage, when we haven't performed any transaction, our system is inconsistent. But after executing, our system will be successfully, must be consistent. It's must point. Erroneous transaction logic can be done to a inconsistence. Okay, so we can say if our database is atomicity, okay, and it is in durable, means there is no problem. We have rollback if there is any problem. Durability, okay, isolation, okay. So if AID, atomicity, isolation, durability, all three holds, then our system will automatically consistent. So that's what it is saying. Now we will talk about acid properties. So a transition is a program execution that access and possibly update various items to preserve the integrity of data. The database system must ensure, okay, whenever a transaction is going to in touch with our database, so it must hold these all four properties, okay. Then if the transition is hold these all properties, it will get into the consistent state, okay. So that what we want. So first is atomicity. We have studied either all operation of the transaction are properly reflected in the database or none are. Okay. So you can see these six steps, okay, are getting done. Okay. if there is any error, okay, despite these three lines are executed, but it has failed at this line, so we say our transaction is none. It is none executed anything. If our transaction, okay, run all these things, then we say our transaction is done. So if it is running all the instruction, then we said our transaction is what? Properly atomicity, and not to not atomicity. Consistent execution of a transaction in isolation preserve the consistency of the databases, means one by one, okay, then our system will be consistent. Isolation, although multiple transactions may execute concurrently, each transaction must be unaware of the other concurrently executing transaction. Means in our system there are many transactions, they are running parallelly, but they don't even know that the presence of the another other transaction. If T1 is running, then he knows that it is only the present in the system, but he don't know that there are many transactions are present in the system, okay. So each transaction knows that he is only the system, but he don't know there are many transactions also running parallelly. So that's what the our isolation. Durability, after transaction complete successfully, the changes it has made to the database persist even if there is system failure. Means we have to roll back and again run the transaction and going on. This will lead us to durability. So this is the main four properties which hold the every transaction, okay. So this is all about the asset properties. Thank you.